All right, in this next demonstration, we're going to actually take a look at capacitor. That's this guy right here. Um, the capacitance, or the amount that will store in a capacitor, is written right here. This is a 1000 microfarad capacitor, which refers to how much charge this capacitor can hold. You can also see that there are little guys here. They have the number 2.2 on them, which means that there's 2.2 microfarads. So this one's roughly 500 times bigger than this one. And really all a capacitor is a bucket for charge. If you want to store charge, you put this in with your circuit and the charge will build up into it. But it has a neat little effect that the more charge stored in it, the less current can run through it. And so it becomes a really handy little tool for timing circuits. Now you'll notice that this has a long pin and a short pin, just like a diode. And the same rule applies. The longer pin needs to connect to the positive side of your circuit, and the shorter pin to the negative. So you can see I've got a circuit here where I've got a resistor, which is a third band is red, which means this would be brown, black, red, which would be 1, 0, with 3 zeros following it. So that would be a 10,000 ohm capacitor, or sorry, 10,000 ohm resistor. I'm going to take the positive of my capacitor and hook that in here, and the negative I'm going to put into here, so that now what should happen is the charge, the positive, should start flowing into this capacitor, allowing the negative to flow in from the other side. So for at least a little bit, we're going to have a current running through this light bulb. But watch what happens when I leave it plugged in. Okay, so initially the light comes on, but if you notice, the light on that little bulb is very quickly starting to diminish and turn off. And that's because this is starting to fill up, and as it fills up, its ability to hold more charge goes down, and so the current will actually slow down. Now if I actually take that, and this now contains that charge that went through this light bulb, and I reverse it. Now this is interesting because we're not going to hook this onto the battery this time. We're going to say that the long pin, which is a positive, is actually going to be the source of my charge. Which means that if I now, with that reverse capacitor, and I take these two leads and hook them up just to each other, watch what happens. See, the light came on because it had all that charge in it, and now it'll start to dim down as it runs out of charge. Now these kind of circuits are very common. They're typically used in timing circuits, also in filtering circuits, where you might have a waveform coming in that's going up and down and you need to filter out noise. In a timing circuit, such as the signal light on a car, the amount of charge would actually trigger a switch, allowing it to first charge up with the light on and then discharge with the light off, and that just triggers back and forth. Let me know if you have any questions on either of these, and enjoy your box.